Hey everybody, Miss Dietrich here. We're going to take a look at how to use models to help you figure out the quotient for mixed number division. So let's start out with something easy and then we'll kind of work our way up to something a little more difficult. If we take a look at this question, they're talking about 2.5 divided by 1/6. So I want to make sure everybody understands where the 2.5 comes from because we're talking about how many hexagons do we have. So I'm just going to attempt to trace one of the hexagons. Okay, there's one, right? This would make 2, and then this is a half of a hexagon, so that's 2.5. Now what we're trying to figure out is we're trying to figure out how many 1/6s do we have in the 2.5 hexagons. So I'm just going to trace one of the 1/6s. That's one right there. So if this is 1, see here's another one right here, that makes 2, and we don't have to trace them. Hopefully you can see. This would be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we know the answer is 15. Now, if we were going to do the standard algorithm for this, how would we do that? We would turn this into an improper fraction. So how many seconds is that equal to? We would do 2 times 2, which is 4, plus the 1 would be 5. And we would say, divide that by 1/6. We would say to ourselves, keep, change, flip. We would do the 5/2 times the reciprocal of this would be 6/1. We would take advantage of the fact that we have a way to simplify these factors by dividing by 2. And if we did 5 times 3, that would be equal to 15. And 1 times 1 is 1. And isn't 15 divided by 1 15? So we can get 15 doing the standard algorithm, or we can get 15 by just counting. Now, if we were going to do this on a number line, then we would probably want to use a common denominator and we'd come up with 12ths, right? So let's take a look at it on a number line in case you like number lines better. If we rethink 2.5 as something 12ths, so remember this is equal to 5/2, so let's just rewrite what that is. 5/2, if we have to rethink that as 12ths, two times 6 would give us that. So if we did 5 times 6, then that would equal 30/12. So if we were going to model the same idea of 2.5 on a number line instead, let's take a look at what that would look like. 30/12. Now, if we wanted to figure out how many groups of 1/6 do we have, then we would circle our 1/6 group. But I want to remind you that 1/6, how many 12ths would that be? It would be 2/12, right? Because 1 times 2 is 2. So let's circle our 15 groups of 1/6. We'll do it in blue. So here's a group. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Whoops, that one's not really good. And then that last group is 15. So 15 groups. So either doing a number line, and if you're using a number line, it's a good idea to get a common denominator. So if we do, actually, we could have probably used, actually 12ths is probably a little bit better, but I wonder if we could have used 6s instead to get the answer that way. But you can still see we have 15 groups. All right, so let's take a look at another type of a problem. This one we have 3 1/3. So do you see the 1, 2, 3 1/3 of the hexagon? So it's still a hexagon. So let's just make sure we see that it's still a hexagon, even though I don't like these because it kind of almost looks like a cube, doesn't it? Kind of looks like a cube, but it's still a hexagon. If I pull that away from the image, you can see that it's a hexagon, even though I didn't trace it very well, but I just want to point that out. Now, if we look for our groups of 1/3, this is 1/3 of the hexagon. And if we count how many of those we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know the answer is 10 by looking at the picture. Now, if we did the standard algorithm to get 10, we would rename this as an improper fraction by multiplying 3 times 3, which is 9, and adding in the 1, which would be 10 thirds. So I'm going to write that over here, 10 thirds, and we're dividing that by 1/3. Now, when you do have a common denominator, by the way, I should mention that it's not an accident that 10 divided by 1 is 10. But if we were going to go ahead and proceed with the standard algorithm for this, we would change flip, keep the 10 thirds, change that to multiply, and flip this to its reciprocal, which would be 3/1. We would take advantage of the fact that we can simplify these factors by dividing by 3. And wouldn't 10 times 1 equal 10? Wouldn't 1 times 1 equal 1? And doesn't 10 divided by 1 equal 10? All right, so that's the algorithm method. And by using the model, drawing a model, we can get 10 by just simple counting. All right, let's take a look at a question like this, because I think this one's a little bit tricky. It says the model below shows or represents a division problem, and they want to know which equation is represented by the model. Now, let's first figure out what we have. So what we have is what they're showing you in this gray area, right? So if we were to look at that on the number line, let's take a look at what is that. That's equal to this amount, right? And wouldn't that be 2 1/3, right? Isn't that 2 1/3 on the number line? And they're breaking that up into equal groups of 2/3. So see how this is a group of 2/3, right? So they're breaking that up into groups of 2/3. So there's 1, 2, 3, and we don't quite have that fourth group, right? We don't quite have that fourth group, because if I circle something that's the same size as the other ovals, if I do that, so let me just see, if we look at what's shaded here in red, we have 1, 2, 3, and what fraction is this red piece of this? Now, I wonder if it's easier for you to see it if we use the actual model that they have. So that's one group of 2/3. Here's the second group of 2/3. Here's the third group of 2/3. But again, we don't have that fourth group. So if we think about that last rectangle, so this last rectangle right here, even though I didn't draw that perfectly, you have to ask yourself, this piece here, which let me attempt to trace that in blue. This piece here, which I didn't do very well there, but if I just think about that, I'll just separate it out. What fraction of the green box is the blue box? And maybe it's easier to see it in here. What fraction of the blue box is the green box? It would be half of it, right? So we have 1, 2, 3 complete green boxes and a half of that fourth green box. So it would be 3.5, right? So we started out with 2 1/3 as our dividend. So see that these two both have the right dividend. These don't. So that's not a contender. That's not a contender anymore. So to figure out from the remaining choices, if we look again at choices A and B, we're breaking it up into groups of 2/3. So they both show breaking it up into groups of 2/3, right? Here's a group, here's a group, here's a group, here's a group. But the answer, this one is showing 3.5, this one's showing 3 1/3. If we did the standard algorithm, if we weren't able to see it in the picture, if we did the standard algorithm, we would take the 2 1/3 and turn that into an improper fraction. And wouldn't that be equal to this times this is 6 plus 1 is 7. And we're breaking that up into equal groups of 2/3. So it's basically 7/3 divided by 2/3. If we did keep, change, flip, keep the 7/3, change this to multiply, flip this to its reciprocal, then take advantage of the fact that we can simplify our factors here by dividing by 3. And if we did 7 times 1, wouldn't that equal 7? And if we did 1 times 2, wouldn't that equal 2? So to differentiate between these two, when the picture doesn't work for you, then you need to do the algorithm. You need to finish 7 divided by 2. So numerator divided by denominator. And doesn't that go in? We knew it went in 3 times, and they're showing you that. And if we do 2 times 3, doesn't that equal 6? And if we subtract, we get 1 left over. So 1 this remainder becomes your numerator, and whatever this is becomes your denominator. So that confirms it, that we're looking at choice A as being correct, and we're rejecting choice B as not being correct. And the picture shows 3.5, does it not? See, 1, 2, 3.5 is what's shaded in gray. So if I erase all this stuff again, the gray part is 3.5, right? If we look at this and look at them as the three separate boxes, it would be 3.5. All right, let's look at another one that's kind of like that. Which expression is modeled by the diagram? So first we have to figure out what's the thing that's being broken up into equal chunks. So that thing, and let's model it on the number line, they're showing you 3 1/4. So I'm just going to trace 3 1/4, much like we've done in class. 3 1/4, right? 3 1/4 is what I've traced here. Now, are we breaking that up into equal groups of 3/4? Is that what we're doing? So here's one group of 3/4, right there. That's one group. And if I clone that, now I have two groups. If I clone that, now I have, oh darn it. Let's see if I can move this. Now I have three groups. If I clone that, there's four groups. Now if I clone this, I don't quite have that fifth group, right? I don't quite have that fifth group. So we can see it's 4 and a little more, right? It's 4 and a little more. Now, if we were to actually come up with the answer, wouldn't this red piece be 1/3? If I kind of line that up a little bit better. It's 1/3 of that green, that last chunk. Now, let's look at the choices here. We're not talking about 3 as being our dividend, right? So that's off the list. And we're not taking 1/4 and breaking them up in equal chunks, so that's off the list. And why is B wrong? B is wrong because this is the divisor. We're breaking it up into equal chunks of 3/4, so they have that in the dividend position, so that's wrong. So if we take a look at choice A, that's probably it. Now, to confirm that it is, it's not a bad idea to do the algorithm to see if it matches the picture. So if we were going to turn 3 1/4 into an improper fraction, we would multiply this times this and get 12, plus the one more is 13. And 3 1/4 divided by 3/4, recall, is the same thing as multiplying by the reciprocal of the divisor, which we would flip that to being 4/3. And wouldn't we take advantage of the fact that we can simplify our factors here by dividing by 4? And if we go across and do 13 times 1, we get 13. If we do 1 times 3, we get 3. And if we do 13 divided by 3, isn't that going to go in 4 times? Get the 12 with the 1 left over. So it's 4 1/3. And isn't this last chunk? See, we have the 1, 2, 3, 4, and we have one out of, if you look here, see how there's 1, 2, 3 chunks that are that size? And we have 1/3 of it. 4 1/3 would be the answer. So that confirms it, that choice A is correct. All right, let's take a look at one more example. How about, let me find the one that I like. Where is it? Sorry that I'm making you dizzy. All right, so let's take a look at this one. It says a science teacher has 1 2/3 cups of baking soda. She performs an experiment for her students by mixing 1/6 cup of baking soda with vinegar. If the teacher uses the same amount of baking soda for each experiment, how many times can she perform the experiment? So we're really finding out how many equal groups of 1/6 are in 1 2/3. Now, if we're going to model this, we would want to think of a common denominator, and we would probably use 6s. Why? Because if we were adding these two things, right, wouldn't we use 6s for? Now, let's rethink 1 2/3. First is an improper fraction. So if we think about how many thirds that's equal to, we would do 3 times 1, which is 3, and then add in the 2, which is 5. That's equal to 5/3. Now, if we would want to think about that as 6s, then we would put a 6 here, and we would ask ourselves, 3 times what equals 6? We'd come up with 2. And we do 5 times 2 to get 10. So basically this number here, right here, if we model it, would be 10 sixes on a number line. 10 sixes would be that. And we want to see how many groups of 1 6 we have on this red line. Here's a group of 1 6 right here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 groups of 1 6. So we know the answer is 10. Now, if we were going to do the algorithm for this, we would probably use this equivalent of 1 2/3, the improper fraction. So let's take a look at that. 5/3. And we're breaking that up into equal groups of 1 6. We would say to ourselves, keep, change, flip. We would keep the 5/3. We would change this to multiply. And we would flip this to 6/1. And we would take advantage of the fact that we can simplify our factors. We have a common factor of 3. Divide that by 3 and get 1. Divide that by 3 and get 2. And then if we finish up, 5 times 2 is 10. 1 times 1 is 1. And isn't 10 divided by 1 10? So either draw a number line and model it and get 10 groups of 1 6, or do the algorithm and get 10. All right, so if you need more help on this topic, make sure you reach out, and hopefully you found these videos helpful.